Lesson 3 of Chapter 5, Properties of Operations. And in this lesson, we go back to the essential question: how can you use numbers and symbols to represent mathematical ideas? So, in the previous lessons, we talked about algebraic expressions, we talked about sequences, and we're going to expand on those concepts. And if we are going to scan this lesson, these are two things that we will learn in this lesson. First, we will learn the properties of operations, and we will learn to simplify algebraic expressions. Remember what we know what algebraic expressions are when we go back to lesson number 1 of chapter 5. The vocabulary that we are going to be learning are these: commutative property, associative property, property, additive identity property, multiplicative identity property, multiplicative property of zero, and the word counter example. These are the relevant standards, okay, that we are going to be using for this lesson, okay? So let's take a look at the properties of operations right away. So the first thing that we are going to be learning is the commutative property. So the commutative property states, okay, that the order in which the numbers are added or multiplied does not change the sum of the product. So basically, take a look at the word order. That means you're changing the order, but it will not change the sum or the product. Let's take a look at addition and see how sum is not changed. In addition, as in symbols, a plus b is the same as b plus a. Good example would be 6 plus 1 is the same as 1 plus 6. You notice that the order changed: 6 plus 1 to 1 plus 6, a plus b to b plus a. But on the example, you notice also that the sum does not, the sum is equal. 6 plus 1 is 7, 1 plus 6 is 7. So the sum does not change. It's the same thing with multiplication. In symbols, we can say that a times b is the same as b times a. And if we take a look at an example, 7 times 3 will always be 3 times 7. So the product of 7 times 3 is 21. The product of 3 times 7 is also 21. So if we change the order of the factors, the product will still be the same. In this case, if we change the order of the addends, the sum will still be the same. Okay? So the second property that we are going to be discussing is what we call the associative property. It states that the way in which the numbers are grouped when they are added or multiplied does not change the sum or the product. Again, the word here, the key word here is grouped. Okay, that means you will see parentheses and all other grouping symbols. But for our purposes, we'll just look at parentheses. Okay, let's take a look at how the associative property works with addition. So with addition, okay, in symbols, A, okay, plus the quantity B plus C is the same as the quantity A plus B plus C. Now, if you notice here, let me take this out. If you notice in this symbols, in this equation right here, okay, look at the order A, B, and C, A, B, and C. The order did not change. What changed was the parentheses. Instead of B plus C being in grouped together, it's A and B now being grouped together on the right side of the equation. Now, as an example, look at 2 plus the quantity 3 plus 8 is the same as the quantity 2 plus 3 plus 8. Again, the order did not change: 2, 3, and 8, 2, 3, and 8. What changed was the parentheses. Here, 3 plus 8 was grouped, and on the other side of the equation, 2 plus 3 was grouped. But if you notice, 3 plus 8, if we do our order of operations, is 11, plus 2 is 13. Okay? Again, if we do our order of operations, we do what's inside the parentheses first. 2 plus 3 is 5, plus 8 is 13. Now, if you notice, okay, the sum will be the same. They're both 13. And that holds true for multiplication as well. Okay, so in multiplication, when we have A times the quantity B times C, it's the same as the quantity A times B times C. Again, the order did not change, A, B, C, A, B, C, but the parentheses or the grouping changed. B times C was grouped here, A times B was grouped on the other side of the equation. Now, if we take a look at an example, 3 times the quantity 4 times 5 is equal to the quantity 3 times 4 times 5. Again, the order did not change, 3, 4, 5. The grouping changed. Here you multiply 4 times 5 first before you multiply it by 3. Here you multiply 3 times 4 before you multiply it by 5. Now if you notice, this is 20 times 3 is 60. This is 12 times 5 is also 60. So if you notice that this is how the associative property works in both addition and multiplication. Okay? Now let's take a look at what the meaning of the word property is. So we've talked about the commutative property and the associative property, but what does the word property mean? Okay, so a property is a statement that is true for any number. The following properties are also true for any number. So again, when you talk about property, it's true for any number. So when you use associative property, it will always be true for addition and multiplication. And if you use a commutative property, it will always be true for any number if you use addition or multiplication. Okay? So let's take a look at the rest of the other properties that we will be discussing here. And the rest of the properties, let's start off with, okay, the first one, which is the additive identity. When 0 is added to any number, the sum is the number. And that's the reason why it's called identity. The number keeps its identity when you add a 0 to it. In symbols, it means a plus 0 is equal to a, or 0 plus a is equal to a. Again, if you notice, this is following the commutative property of addition. As an example, 9 plus 0 is 9, 0 plus 9 is 9. If you notice, it keeps the identity of the number. 9 plus 0, 9. 0 plus 9, 9. Okay? Okay, the next property is related to additive identity is the multiplicative identity. Okay, when any number is multiplied by 1, the product is the number. Again, it keeps the identity, but this time in multiplication. So the multiplicative identity simply tells us that anything multiplied by 1 will always be the same number. The number will keep its identity. 5 times 1 is 5, 1 times 5 is 5. Okay, those are the examples. And finally, the multiplicative property of 0, sometimes called the zero property, simply states that anything multiplied by 0 will always be 0. Okay, so anything multiplied by 0 will always be 0. Like the example here, 8 times 0 times 8 is also 0. Okay? Let's take a look at example number 1, see how that works. Name the property shown by the statement. You have 2 times 5, 2 times the quantity 5 times n equals 2 times 5, the quantity 2 times 5 times n. Now, if you notice, the order did not change, 2, 5n, 2, 5n. Only the grouping changed. 5 times n was grouped here. This one, 2 times 5 is grouped. Okay? So, when you see those parentheses, you will right away associate relate it to the associative property because of the order not changing, and you have grouping symbols that change. So the order of the numbers in the variable did not change, but their grouping did. This is the associative property of multiplication. Okay? Multiplication, because of that, if this is plus, then this is the associative property of addition. Okay? Do the got it problems, and let's see if you understand all the properties that we just discussed. Okay? Let's take a look at example number 2. State whether the following conjecture is true or false. Remember, okay, when you talk about the word conjecture, it talks about sort of a conclusion, okay, without proof. So, in other words, when we say state the following conjecture, state the following conclusion if it's true or not, true or false. If false, provide a counter example. So a counter example is an example that will basically disprove or prove a particular conjecture. Okay, let's take a look at it and let's see how we are going to work it out. So in this particular example, example number 2, the statement is division of whole numbers is commutative. Okay, write two division expressions using the commutative property. Basically saying, if you use division instead of multiplication or addition, is this true? Okay, will it work? So let's take an example. If I have 15 divided by 3, is this the same as 3 divided by 15? Of course, the answer is false, right? Because 15 divided by 3 is, okay, 15 divided by 3 is 5, and 3 divided by 15 is 1/5 right here, okay? So the conjecture is false. The conclusion is false. We found a counterexample. This is the counterexample that proves that this conjecture is false. Okay? So that is 15 divided by 3 is not equal to 3 divided by 15. So division is not commutative. Remember that division is not commutative. So when I say 1 divided by 5, it is not the same as 5 divided by 1, which is a basic misconception. 1 divided by 5 is not the same as 5 divided by 1. 1 divided by 5 is 1/5. 5 divided by 1 is 5. Big difference between the two. Okay? Do the got it problem, and let's see if you understand that example. Let's take a look at example number 3. In example number 3, Alana wants to buy a sweater that costs $38, sunglasses that cost $14, and a pair of jeans that costs $28, and a t-shirt that costs $16. Use mental math to find the total cost before tax. Okay? So you have a sweater, 38 bucks, glasses, 14, jeans, 22, and a shirt that costs 16 bucks. So first we write an expression. Write an expression for the total cost. So you can arrange the numbers using the properties of math. Look for sums that are multiples of 10. Okay, now what does that mean? It simply means that I have 38 plus 14 plus 22 plus 16. I want to make my addition faster, so I want to look at for sums that are multiples of 10. I know that if I add 38 and 22, that would give me 60. And if I add 14 plus 16, that would give me 30. Those are the sums that we want. And therefore, I will rearrange them. So this becomes 38 plus 22 using the commutative property of addition plus 14 plus 16. Okay? Then I use the associative property of right here. The associative property, I group 38 plus 22, meaning I add them first. And then I group 14 plus 16, which gives me 60 plus 30 right here. And the sum is 90. So the total cost of the items is $90. And that's how you use the properties for you to be able to add numbers faster mentally, okay, by finding sums that are multiples of 10. Do the got it problem and let's see if you understand. Example number 3, okay? And finally, two last examples. Example number 4, simplify each expression, justify each step. So we want to simplify each expression here. So if you notice, we have first the quantity 7 plus g plus 5, okay? Now, first and foremost, we cannot add 7 plus g. You cannot add g to 7 because you don't know the value of g. But we know that we can add 7 and 5, okay? So basically, the first thing we need to do is we need to use the commutative property of addition. 7 plus g plus 5, which is what we just copied the one on top, now becomes g plus 7 plus 5. We simply change the order of 7 plus g to g plus 7. And after that, we now use the associative property where we change the grouping from g plus 7 to 7 plus 5. Look at the order, it does not change here. So we're using the associative property. Now we can add 7 plus 5. Okay, so 7 plus 5 now is equal to 12. So g plus 12 will be our simplest form of the expression. Again, we cannot add g plus 12 simply because we don't know the value of g. That's a variable. Okay, it depends on what the value of g is for us to find the value of the entire expression. Since we don't know the value of g, we are left with this expression. Okay. Finally, example number 5, m times 11 times m. Okay, again, we rewrite this down here. So this becomes m times 11 times m. Okay, using the commutative property of multiplication, we change the order of m times 11 to 11 times m times m. Then using again the associative property, okay, we change the grouping from 11 times m to m times m. Okay, and we know that m times m is the same as m to the second power. So the simplest form of this expression is 11m squared. Okay, so this is how simple it will get. We cannot make it any simpler. Okay, so let's do the got it problem and let's see if you understand examples 4 and 5. And that's the end of our lesson. Thank you for watching.